I think I'd be gracious. I mean, it certainly sounds like we're seeing this as design is in progress and what it could do, how would like go about doing it, how far
So this is a PCE concept that is not well, maybe you have a good reason. Very good.
Okay, the big hand is on the, and the little hand is on the, so it's time to get started.
While David brings up, oh, he's already there. This is the SCTP session. Michael's going to come to talk because he likes representing the SCTP people.
Yeah, Michael Tuxen, this is about, what is it, net support. Okay, so this is just as a short explanation. This is a version of NET for SCTP. NETs don't support SCTP in an efficient way, in the sense that normally NET boxes change IP addresses and port numbers, and you can do this for SCTP the same way you do it for TCP or UDP. That's not a problem, but the problem comes up when you have multi-homing, you have multiple paths, and you have NET boxes on these paths which are not synchronized, so they might change the port numbers independently, and that doesn't work for SCTP. If you change the port number, you have to recompute checksums. That's also something which is pretty heavy for SCTP. So this document specifies a method of doing NET without changing the port numbers. It uses a specific protocol-specific field, the verification tag, as a sort of connection identifier. And this is how you handle collisions, that when you have an incoming packet, you need to figure out to which node in the private network you send the packet to. If you want to see the details, you can read the document. It's specified what you do, what the netbox does, what the endpoint has to do. They are sort of cooperating for this. And there's a whole section with examples and message flows and how the net table gets filled in. So that's there. So what's the status of this document? This is pretty old, 12th release. We have finally addressed comments from Karen we got some time ago. I went through the document, clarified a lot of things, looked at consistency, figured out that we were using not the IP addresses we should use for examples and drafts. I changed that. There was one comment raised some time ago that this document should be split in, let's say, about 2 parts. One part to be read by implementers for netboxes, one part to be read by implementers of endpoints. And I didn't do it because I realized that some of the sections are really applied to both. So the packet format has to be understood by both. The introduction is better read by both. Also the examples. So I didn't do that. And the authors consider this document finished, except for Gori read it, I think 2 days ago, and provided some editorial comments, I would say. So he made a pretty good suggestion for increasing readability, increasing consistency with documents from Behave, and he also suggested to not really split the documents into 2 parts, but split specific sections into 2 subsections, so that you have subsections which concentrate on the endpoints and the other subjects and does the counterpart for the middle box. This will be integrated in the next revision, which will be submitted pretty soon. And basically, oops, that's the wrong. What?
No, it's the chat. We're working out how to use the tool.
Pardon?
Next slide.
Is there a next
No,
slide?
there isn't one. That's why we.
Okay. So exactly. So the point is, with the next revision, we had up questions.
Maxim Proshin Ericsson, are you aware of any implementations of NAT that support the CTP?
Yes, the NAT implementation in FreeBSD supports an earlier version of this. It might not support it with some correct chunk IDs or something like this.
Okay, as far as I know, Linux doesn't support it, or
Correct.
yeah. So the reason of my question is, I think it would be really good if you describe in the document what will be working if NAT doesn't support SCTP and what will not be working. Because
So if you have,
as you said,
so it's pretty hard for me to describe what a NAT box does, which does not follow the spec, because
no, I mean if it doesn't support it completely. I mean, it only, replaces IP addresses.
Just a straight IP NAT. Is that what you're saying?
Yes.
Okay.
but this is protocols. I have seen different things. So some nodes just allow something like an exposed host, so where you configure all packets you don't understand sent to this box. That's working also for SCTP in my testing.
Yeah.
I saw some which do this, but it's very hard to say something about devices which are not following a spec. I have no idea what they do.
I think the document's purpose is to describe, here are NAT implementers, here's how to support SCTP, and here SCTP folks, here's some considerations for you as well. It's not to say, oh, and by the way, if you don't have this NAT support, all these other things would happen. That sounds more something that would have come out of Behave or some other document, but it would be another document, I would think.
Effectively, this is Behave for this one.
The document is to SCTP developers and to NAT developers, right?
Yes.
Correct.
If I, SCTP developer, implement this document, it doesn't really mean that everything will be working, right? And I want to understand what will not be working if NAT doesn't support SCTP. If I implement this in SCTP only.
If you're capable of implementing SCTP and you cannot fathom the consequences of a NAT not doing its side, I would question the person who's able to implement SCTP.
Wait a minute. I'm not sure what the question is. Let me try the question and see if I understand. The question is, if you implement the SCTP extensions described in the draft for NAT traversal, and then find a NAT that doesn't implement the NAT part?
Yes.
Okay. That's a good question, Michael. What happens if you just implement the end host association changes, etc., and then find an old-fashioned NAT?
It looks like a perfect thing for me. So it will not detect any, the question is what happened. So the NAT always had, I even don't need to implement this stuff. I can run normal SCTP through that and it will break the same way or not. It depends on what it means that this NAT supports SCTP.
I'm hoping I can help. A NAT, if the packets get through the NAT, then something interesting is going on, because how does the NAT know which host to send the packets to inside?
Yeah.
And I think there may be NATs.
There are.
Mike,
there are NATs that will just map the IP address when it doesn't understand the protocol.
But it says, oh, if I see this product, because you saw one of your inside hosts initiate something on this protocol that you know nothing about, maybe I should send all the packets that come from outside with that protocol.
They use VPNs, yeah.
And there might be NATs that do that, or there might be NAT things where you could configure that if packets show up with this protocol, please send them to this.
Lots of ugly stuff happens here.
So But it almost, I mean, this, I'm sympathetic that this almost doesn't make sense, but maybe that's what you had in mind.
So the point is, what the endpoint, basically high level, what the endpoint does, if he supports this NAT thing, he avoids putting IP addresses in the in the IP payload, and that's a good thing also for NATs not supporting this. So it can work to the amount of what this NAT implementation has done. If that's a HTTP packet through, that's fine. If it how it behaves in case of two nodes in the private network talk to the same server, I have no idea. It can't make a distinguish. Normally they would use the port number for that, but I have no idea if that works or not, what they do.
I guess you could write some text in the introduction to kind of explain this if it's not already there.
I can
I mean,
write
you can only
something.
say it's undefined, right?
Yeah,
And
I can-
undefined means we have a spec later here in this document that tells you what to do.
I mean, I can write some kind of warnings, but I can't say what will happen.
Seems fair enough. Right. Yeah. And why are we having such a complicated conversation? The answer is because we need people who understand NATs to review this document. So have we got any people lined up as reviewers for this? Would anyone like to review it? Would anyone be kind of coerced into reviewing it if we bribe you in some way? I mean, the document will be clearer. Maxim makes sense. Yes, thank you. Sue? Okay, so we have
Thank you.
some reviewers, and we will try and resurrect parts of the behave expertise from the IETF to go with that. But submit the next one, and we will give it a working group chair review. And if that looks right, we will intend to go to working group last call and solicit reviews.
Perfect.
I suspect that's a tricky job, but we will start it.
Great.
Next draft.
Okay, this is about the document which has left the working group. It's about RFC 4960 erratas, which means it talks about issues which have been found since RFC 4960 has been published. The seventh version addresses all technical and editorial issues which were brought up by the IESG last call. So the sixth version was addressed everything from the working group last call, and then was the IESG last call was requested. The changes include text making only giving references to the erratas filed in the IETF errata system. So I went through all the erratas which were submitted and considered which one were correct. They have corresponding text in this document, but not the other way around. So not every issue we have here is an errata being submitted to this errata system. The references are there. There are some erratas on the website which are not covered by this. These are the erratas which are wrong or have been rejected or whatever. Typos were fixed. Some text clarifications came up. Someone figured out that we missed something in the ICMP text. And so things have been cleaned up. The status of the ISG evaluation is 1 yes. That's normally the ISG member who is responsible for this. 3 times no objection, no records 2, and abstain 8. 1 has a discuss. That is a guy that's Eric Rescola, who has had initially also an abstain, but changed it to a discuss because of the high number of abstain. So he wants, I guess, to discuss with Spencer this. One of the comments which were brought up was that the document is hard to read, especially because the structure is you have sections. Each section describe an issue. and says which text in the ROC gets replaced by a different text. And this is sorted by the time we found the issues. So whenever a new issue came up, a new section was added to the end, and the issue was resolved. So one of the comments was, what happens is there is text which is touched multiple times. So the suggestion was to add for each section a sentence saying the text changes here are final, they are not changed in sections following this one, or this text is changed again in this section. That's not in it right now, so that will be added for next revision, and then the document is with Spencer.
Thank you ever so much. Please don't use the word final. Just because the final version of the BIS document will be decided by working group consensus. So
No, the final-
what you're saying is, yeah, this is not further modified
Within that
in
document.
that document. Yeah,
Yeah.
be clear. And that would be great. That would, I think, really help a lot of people.
Yep.
And I'd be happy to work with that, and then we'll hand it back to Spencer, and I think Spencer knows the right thing to do.
Okay.
Okay, that concludes that. However, there is the notion of a BIS document. Are you planning to open a BIS document after this meeting? Now you have this more or less resolved after these changes?
Yep. So the plan was, until this morning, to submit a 0.0 version of the BIS document being identical to the RFC version, so that we have all the changes in the tracker.
Mhm.
We figured out that the RFC was processed in NROF. So we submitted XML, the RFC editor changed it to NROF, and that's the reason why some of the tables went wrong. So we will see if we can really do this, or if we so the plan is something like use the NROF stuff to submit the old one with all the mistakes, then do a 01 changing the tool chain, and then applying all the changes in one revision, so that we have an 02s, I guess, which is
Okay.
that stuff.
The plan you suggest is fine with the chairs. Please submit a working group 0.0 version. If you need help constructing that 0.0 version, I suggest you go to the RFC editor and see if they can help you with a few tools and goodies to resurrect.
Yeah,
XML.
we will see. So we will submit a 0.0 version as a working group document.
Indeed, that's what
Okay.
you're being asked to do.
Thank you.
But tell us as chairs just before you do it so we can set the approved flag.
Okay, thank you.
Oh, next person, Joe.
Is Joe out there?
Joe, I wonder if you're there remotely. So we've been trying to synchronize with Joe, and I don't think we've done many remote presentations at TSVWG, but if Joe's online, is John Jabber? No. Okay.
Do you want to try impersonating? We've done, you and I both attempted this at various points.
I'm happy to try and impersonate Joe, but I think he said he would be here. So let's just punt the presentation later and try polling Joe again. So we'll skip this one and we'll come back to it before the end of the meeting. So next one.
Bob, L4S.
He only has 20 minutes.
Yeah, and 20 minutes. I think we're up to 4 drafts now, so that's 5 minutes a draft.
You choose.
Well, the first one I'm not talking about at all, so that's a good start. Right, next, or have I got a?
Yeah, it probably works.
All right. A recap. This is the general architecture, this picture. And the motivation for L4S is extremely low queuing delay for all internet traffic eventually, and certainly all applications. Already 1 to 2 orders better than state of the art, about average 500 microseconds versus 5 to 15 milliseconds at best with state of the art active queue management, or hundreds of milliseconds with buffer bloat.
And the architecture is essentially a new congestion control based on data center TCP at the host, and being able to separate out in the network low latency from other traffic in such a way that the bandwidth is shared as if it were just one queue, but the latency is isolated. So essentially it's all about making sure that TCP, classic TCP, is separated out and hopefully will fade away over decades. Right. Well, hopefully it would fade away more quickly, but it won't. Okay, I won't go into any more detail on that, other than to say there's a network part, a host part, and a protocol in between based on the ECN field for the two to know which packets are which. Right, so drafts I'm going to talk about, or this is an outline of the whole talk. Drafts I'm going to talk about today. Not going to talk about the architecture, which is stable and hasn't changed. There's two other working group drafts, one on the identifier, the ECN, identifying the ECN field, which is the ECT1 code point. I'm going to talk about one particular addition to that, which is a condition for when you can use that code point, and it's related to rack, which is probably surprising to many people, and we will come on to that. In the dual queue draft, again, there's a number of changes in each of these drafts, and I'm sort of picking out one in each. That's the major technical change, and in that one, we're getting towards the corner cases in that one, and this is handling unexpected packets in the queue, which I shall talk about briefly. And then there's a draft that's not a working group draft currently. You had it on the chair's introduction as new, but it's actually it was new last time. I presented that last time, so I'm only presenting updates this time, but I will try and give an outline of it as well for those that missed it last time. And then I'm going to give a couple of slides on just a general status of the L4S, a sort of state of the nation on L4S, and end up with next steps. So identifying the modified ECN semantics using the ECT1 code point. The main change is within this draft we have what are sort of parochially called the TCP Prague requirements. That is, I don't think we do mention that term but it's not just for TCP; it's for all transports, and they're essentially requirements that the congestion control must satisfy in order to have the right to use this code point to send into the network. Essentially what it means is that this code point then says this congestion control or this transport is acting in a scalable way and it won't cause a queue, and so on. So it's entitled to go into that very low latency queue. And we've added a fifth requirement, which seems like it's nothing to do with any of the others. So I've got to explain that, and that's what the next few slides do. I won't go into the other four requirements, not enough time. But the fifth requirement, paraphrasing, this isn't the wording in the text. It says a scalable congestion control must detect loss by counting in units of time, not in units of packets. Now this is like the way TCP rack works. And it's not like the way TCP's old 3 DUPAC rule worked. It seems like TCP rack is being picked up very fast. If you don't know what TCP rack is, it's about detecting loss in units of time, not packets, and I'll come on to that on the next slide. But the reason why this is important for L4S is that it then means that link technologies that support L4S can know that all senders sending packets into this queue, into their queue in the network, they can look at this ECT1 code point and they know that means you support detecting loss by time, and it means you can relax your resequencing and reordering requirements in the network And that means you can remove head of line blocking if you're doing things like link layer retransmissions. So I'm going to explain all this, but that's the overview. So quick background on rack. Loss normally is only at the transport layer, at the end-to-end layer, you can't actually know there was a loss in the network. You can only deem that you think there might have been a loss because packets are arriving and there's been a hole because the packet might arrive later. Now, classic TCP uses the 3D packet rule. TCP rack uses a fraction of the round trip time termed the reordering window. So it arms a timer when the next packet arrives after the gap, and then if after that time the packet hasn't appeared, it deems it lost. I've called that epsilon, although it's not called that in their draft because you can't write that in ASCII. But it's certainly what mathematicians think of as a small fraction. Now there's a trade-off over the value of that that fraction. If you have a larger fraction, epsilon, you get less spurious retransmissions. That's before the acts of those packets arrive, you've done a retransmission, and then you discover you shouldn't have done. However, of course, it will take longer to repair genuine losses, where longer is 1 plus epsilon times the round trip time, because it always takes a round trip time at least to repair a loss, because you've got to discover it, and then you've got to wait this extra epsilon. So you don't want epsilon to be too long, otherwise your losses take too long to repair, but you don't want it to be too short, otherwise you do too many retransmissions and waste bandwidth. So rack adapts that reordering window. It starts small so that short flows get losses repaired quickly, but then it goes to longer later. Okay, so all the details are in the rack draft, but that's rack in a nutshell. So what are the benefits of rack to links? And that's why we're saying this is a must for L4S, because they turn out their benefits for the applications and the end systems. Right, so as well as the benefits at layer 4, which are already articulated in the rack draft, it gives you performance improvements at the link layer. And I'm going to try and explain it like this. If you imagine that I'm showing two flows here, one going slowly, one going fast. So there's 12 packets per round trip time is that one with the long packets. So there's 12 packets in that round trip length. And then at either on some faster link or at some future date, things are getting faster, you're sending more packets, 96 packets in this round trip time, just as an example, so 8 times faster. Now, if you have to keep packets in order on that link within 3, you mustn't reorder in greater than 3 packets, because otherwise TCP will fire, consider there's been a loss and fire a retransmission. When the packets are going slowly, you've got 6 milliseconds. You've got 3/12 of that round trip time. When the packets are going fast, 8 times faster, you're at 1/8 of the time. And as things get faster and faster, you've got to keep ordering within microseconds and then nanoseconds as things get faster. In this case, 750 microseconds. Now you might think, well, why does that matter? Because if they come in order, they'll go out in order, and the faster they go, they'll still be in order. But it's because most links, in order to get faster, parallelize. They use multiple channels, particularly over radio links, and then put it back together again afterwards. And so the tighter you make that timing of the resequencing after parallelization, the tighter the clocks have to be. Everything is much more difficult to make fast. So it would be really useful if this thing scaled in such a way that as everything gets faster, you've still got the same amount of time, rather than the time getting squeezed and squeezed as things get faster. Now, so that's the first reason. Gori, do you want to jump in here, or? Yeah, it's about rack, is it? I'll finish the rack bit and then, yeah. So then there's a second benefit of rack to links, and that is if you've got a lossy link, like a radio link, with the three duplicate ACK rule, you quite often have a link layer retransmission going on to heal the radio losses. And then you have a resequencing buffer at the receiver end of the link. So if there's a link layer retransmission going on, so you've got a hole in, you've set some link layer sequence numbers, you've got a hole in that sequence, you hold the packets behind that hole until you do the repair, and then you let the whole buffer go out once you've repaired it. And obviously that delays everything, and in particular it delays all the packets you're holding, which may not even be for the same flow, because this is at the link level, or it may not be for the same stream, you know, if it's quick or something like that. And it's very difficult to know whether they are or not. So you've got your head of line blocking. So with making this rule that you have a certain amount of time in which reordering is allowed, it means that that resequencing buffer can actually just be removed completely. You just forward stuff as you get it. If there's any holes, you do the retransmission, you know, afterwards lazily. That retransmission comes out, and once you've eventually got the packet through, you send it off out of order, but you've got plenty of time to do it. Right? I mean, not plenty of time. You're not. You know, we're talking of, you know, sub-millisecond maybe, or a millisecond or so, but it's at least it's not getting smaller over time. It scales, it scales order one, right? And finally, Gori, one more on this. So why are we making this a must? To use ECD1, a scalable congestion control must not detect loss in units of packets. Why are we disallowing this completely? And it's because unless you disallow it completely, you can't get the benefit of it, because you've still got to support all the flows that might not be doing it. And so when you've got a mix of rack and 3-dupack TCP in the classic queue, you won't be able to get any benefits in the link layer for maybe 20, 30 years until everything has sort of gone out of the system. All the old 3-dupack stuff has gone out of the system. But if we start afresh with this L4S queue and say, no, only do time-based, then we can get those benefits immediately.
Okay. Bob, you've got about 5 minutes.
Yep. Okay.
So Gorify has just 2 comments. The first one is, I don't believe the 30 years thing, because you can do some queuing difference in that other classic queue if you wanted to.
How do you know which ones are rack and which ones aren't?
I said I don't believe the 30 years. Right. The second thing, just as a working group chair comment, when you said why we must have and must not, the working group as a whole has to buy into this as being the way forward, because it has implications. It means RTP-based protocols as currently written will not work. Maybe not. We have to figure out what might work, what might not. And as a working group, we need to listen to Bob and decide to embrace this. Or not, as the case may be.
Yes.
But if we don't embrace it, I think there'll be penalties. So.
Yes, sorry, I should have said that's why I'm talking about this, because it's a cross-layer issue. You know, it's important. Yeah.
Anna Brunström, so I have a question. Doesn't the rack also react to the first 3, the reordering, before it?
Yes, it does, and that's why I've tried to be careful and say rack-like. But so rack starts off.
Not react to loss means that reordering means you can still react to it in the first instance, or it
says it must not detect loss in units of packets. Means that you've got to use time right from the start, whereas rack uses the 3-dupack rule from the start. But I had a session with Yu Chung before he went back, and he's now understood that he's got to try and put that in units of time. I mean, it's not so important for TCP as it is for this case, but if he doesn't do it for TCP, then it will be 30 years, you know, it will be 40 years or 50 years, because we still haven't got rid of that problem.
But I thought that rule was also there because it's actually the fastest way to detect it if you don't have...
if you,
lost it. I thought he had left
Yeah.
that rule there because it was very hard to detect the loss quickly enough otherwise. So
Yeah, when you've got-
once you start to detect reordering, it changes.
it's because you haven't got many packets in the first round trip time, and so it's very difficult to know what time to set. So it's going to be difficult, but we're going to try and work it out. Let's leave it at that for now. Yeah.
Okay.
So,
Yeah.
Bob, you've got a problem because Joe's waiting remotely and
Right.
he needs to take his time slot. So you don't have enough time for the slides you've got.
Okay.
How do you want to use your last 5 minutes?
Right. Okay. I will skip the dual queue stuff
Okay.
and say, could we have comments on the new text? There's a whole new section in there about these unexpected cases. So could we have comments on the list about that? I'll get straight to, I'll skip this and say
Okay.
simply that we've updated the diffserv draft, and the main purpose of this draft was to introduce the idea of using expedited forwarding in the dual queue as well as the ECN for what you might call non-queue building traffic that is not responsive, things like DNS or sort of game sync packets, stuff like that. That's the main reason for this draft. And I'm thinking from feedback I've had from David that maybe all the other stuff in this draft could be either die or be separated out or something, because it seems I wasn't particularly interested in all the other stuff. I thought it was what David wanted me to write, and now David said he's not interested in it.
Okay. Talk offline.
Yep.
You guys can figure
Right.
this. Less is
Okay.
good.
So there's a couple of status updates on L4S, and I just want to pick out one thing on this, and that is the implementation at the bottom there in NS3 is complete, but still evolving. Will be released August 18. That slipped from the last time I said it, and it's been validated by comparing with the original L4S experiments, which are on the left, and essentially very similar results. The ones on the left for a DSL link, the ones on the right are on an Ethernet link, but essentially it shows that the L4S implementation in both must have been, or the experiments must have been valid because they both give the same results, which is good. And there's a number of draft updates. We've heard about most of these. We've heard about Quick ECN. We've heard about everything. I wanted to get, please, just the last slide, which is next steps.
So how many people from the working group have offered comments on the drafts? Is it
Very
mainly
few.
your work?
That's why I want to get to the next steps.
Yeah.
Right? Can you do the last slide?
That
Yep.
one.
Right. So it's I can't say, unfortunately, there's a group of people working on it, and so when I do all the updates to the draft, I'm acting as editor on their behalf, so it looks like I'm the only one doing it. But that situation is going to change, I believe, very soon. And very soon means within weeks. So that's why I'm saying we should now be able to leave the holding pattern, and indeed want to leave the holding pattern. And so I'm going to tidy up piecemeal changes, but I'd now like to start getting reviews of the whole thing, and I shall be getting the people who have been working on it to give reviews, and I'll be encouraging them to put it on the list. I have realized that I will now try and get them to give the comments they're giving to me directly to the list, right? Which is
Please do that. Visibility of
Yep.
why and how would be hugely useful to the working group to understand what's going on as document stabilizes.
Yep.
And you need to come to, are you going to come to Bangkok?
yes, yep.
Excellent. Please figure out what you need to present there and talk to us well ahead of time.
Yep.
And
Okay.
Liz would be happy to figure that out with you.
Yeah, and I'll have a word with David about the diffserv one. Yep.
Okay.
Right.
I'm going to sign up as a reviewer for that one. Okay.
Thank you.
Yeah. Okay. Joe, you out there? I see his name up there, but he has to come into the speaker's queue or something? Click on his name, but
He has. What does Joe have to press?
yeah, Joe, you need to request to speak.
What? He is in presenter mode. Yeah. We press the red button, see what happens. I don't think anything will happen.
Nope, nothing. Yeah, he's here in.
Maybe Joe, you can enter this queue anyway, and we can get you that way in the room. Or whoever is in Java can write meet echo. Okay.
All right. Should we go to the last presentation and then come back this one after we solve this? Take another shot at it?
Okay, can someone in the Java room tell Joe to put meet echo on in the Java and see if they can give him help? Okay.
All right.
Then we'll. Oh, just a moment.
Here we go.
We're ready.
Here we go. Joe, you out there? Hello? No, not fixed. All right. Let's do IPQS and come back to this and see if it gets fixed. So I want to say a little bit about why this draft is here. IETF has an interesting experience in trying to do resource reservation protocols. RSVP has wound up being used only as a traffic engineering protocol. NSYS has failed, it's basic failure. And anybody trying again with either of those protocol designs is going to run into all kinds of interesting and not particularly nice path diversity issues. This is an idea for how to build a reservation protocol that's starting from a different place. And with that, I'll introduce Ying Zhen and have her explain.
Thanks for the introduction. Hello, everyone. My name is Ying Zhen. So this is a resource reservation protocol in IPv6. The original draft was written in 6 months and presented in IETF 100. So for this is a rewritten of the original one. Thanks to the Tsvwg chairs, we address a lot of comments we have received, and this draft we focus more on the resource reservation part. So what we are trying to do, we want to have a new reservation protocol in IPv6 through in-band signaling using IPv6 extension header. The design principles we have, we want it to be backward compatible, which means it can coexist with regular traffic. The service we are providing here is meant to be used by applications who have the high bandwidth, low latency requirement. It's not meant to be used by all packet, all flows. And right now we are targeting for only one service domain. So how it works, we're using IPv6 extension headers. If you look at your network, you don't need to configure this header, or the header doesn't need to be processed by every single router along the path. You only need to have it, the resource reservation on the router where the congestion might happen, your network choking points. So what we do when we get the extension headers, we make the bandwidth reservation, the queuing reservation is processed by the NPU, now CPU, because it's an inbound signaling. We want it to be distributedly processed. And that's how we achieve better scalability. We have different granularities for flows. The finest we can do is really flow level. That's like the 5 different tuples you can use to figure out what a flow is. And when we also have transport level, pretty much means different protocols. The terminal kind of level, that's based on the source destination address. And we also have the different serve level. That's like packet, the flow are defined by different DSCP values. So on scalability and performance issues, this so far, I think that's the comments we got the most. And this is a classic question in all these kind of proposals. So even for in-band signaling to do QS, to resolve the QS issue, it's not, it has been proposed before, and it failed because of most cases because of scalability issue. The way we are doing it now, we use distributed processing. Because of modern hardware, we have the NPU that has the capability to do this kind of processing. So that makes it different from before. What we couldn't do before might be possible now. So we want to try this again. So we have an example here. Let's see. So we have an example here. This is really large number scalability. Let's say if the largest part right now is like 400 gig, and that has one NPU, and let's assume like maybe half of the bandwidth we need to have resource reservation. So that's pretty much, that's 200 gig. And let's assume per flow, we have per flow level reservation. Then one flow is at 100 meg. Then we will need 2000 queues for this one interface. And currently, the modern hardware can do this. It can provide more than 2000 queues. And if we look at reality, we usually have, for real applications like network-based AR/VR, the bandwidth requirement is larger than 100 meg, and we have less number of flows. So that means in reality, the scalability issue is not as worse as the example I have here. So I just use DSCP as an example. So this slide shows how the classic DiffServ works. When you have usually we have this, this is just an example. So we have this bandwidth reserved for a certain DSCP value. Then the queuing is sort of, you have the same configuration or even different. It's still prefab config on every router. So no matter what your flow is, like here you have this 2 flows for this DSCP value, and later on this router you have more flows, but you still have the same queuing capacity. But with the new proposal, the queuing and scheduling are dynamic change based on the number of flows you have in this DSCP class. The use cases for this one, because we are really providing the bandwidth, high bandwidth, guaranteed low latency service. So we have use cases in .NET. I'm not going to go to talk about a lot of details about this one. So basically, we can use this to interconnect TSN network. We have different ways to make connections, but that's more like a routing question instead of resource reservation question. We can also use it in the question PanRG has trying to work on. So just to make sure you have guaranteed resources. So in summary, we are just proposing a new resource reservation protocol in IPv6 through in-band signaling. We are, because of modern hardware, we see this as a new opportunity, and this draft, we have it as an information-based. So we want to see whether we can open a new door.
Can I ask a couple of questions on the last slide, please? The last slide. The ETSI work item says it will publish the spec in August. Is that still the plan?
Sorry?
The ETSI work item appears to say you're going to publish the spec in August. Is that still the plan from ETSI?
Yes.
Okay. Is that open to change control by the IETF, or is that just a document that's going to be published by ETSI independently?
I suppose it's ETSI independently.
Okay. Is that document made available to the IETF to look at? Or is it
yes,
private to ETSI?
It's public information. You can Google and see it.
We can get a copy of that. Okay. And what happens in the ETSI group when this finishes? Is ETSI progressing further standards in the NGP group, or is this the end of this particular specification there?
I think we'll see the comments we collect from IETF. So these two are related and also sort of independent of each other.
Yeah.
So it doesn't necessarily mean they have to be identical.
Sure, and it's just to clear the ground so we know exactly what happens if an IETF document emerges from this. Now we can take some questions from the floor.
Hi, Kyle Rose. I admit I haven't read the draft, so I might have missed something here. You mentioned that there's a big assumption that the number of flows involved is fairly small, relatively speaking, because you're assuming it's very high bandwidth flows. What happens if a misconfigured device just spews out a bunch of small flows with a request for guaranteed resources? Are there any protections discussed to prevent that from happening?
Yes, we do have some basic mechanism to do authentication. So you have to pass that in order to make a resource reservation.
And the NPU can do this? Anyway, okay, thanks.
They can be authentic, but numerous. Yeah.
Sooner or later, you go tilt.
Yeah. Authentic. I mean, RSVP had a blocking capability, so under load it could push back.
Yes.
Yeah, I think you need that, not just authentication. But anyway, sorry, Bob Briscoe. That wasn't my point.
Bob, what's your point?
Right. I would like to see in this draft. I read the first version. I haven't read the second. I'd like to see much more time spent on understanding why this didn't happen before, rather than just assuming its scalability, because I don't think it was. And even if it was, there were other reasons. Right?
Indeed. So we have a very rich heritage in the IETF from ST2 onwards with RSVP in its various forms and NSYS and goodness knows what else, where we try to do things. Technology has changed, as you explained, and that is an important thing for us to consider, but we can't forget all the stuff we've done in the past.
Like I said, in-band signaling itself is not new. Even just in-band signaling for QoS has been proposed before.
Yeah.
So
that isn't what I'm saying.
But the problem is this kind of signaling has to be processed at almost line speed, and it has to be. You don't want it to be processed
not
by
what I'm
CPU.
saying. Can you listen, please? You need to look at all the reasons, not just scalability. Let me give you one. Right? I was heavily involved in the PCN work to make RSVP scalable, for instance, right? And we deployed in the company I was working for at the time, British Telecom. We deployed a reservation system for QoS for use by ISPs, not for end users. For their large, content providers, all the rest of it. It was used quite heavily for about 10 years, and then it was taken out because it had never once said no.
Well,
And
I
it was
think
extremely expensive, and it had never said no
so.
in 10 years.
If you know all the pitfalls for this kind of solution, we are very happy to learn it.
No, it wasn't a pitfall. It just wasn't necessary because bandwidth had grown to the point where all the use cases for it could be catered for. And so what we think of as a large amount of bandwidth now, by the time you get this through standards and implemented, you will have so much bandwidth for the things you think are large at the moment, they will be tiny. And that's the problem.
But
Yeah.
Well, that
So
sounds
it's
like
not
a
only-
discussion you can't actually
I know.
talk about now, Bob. So it's just something that you probably have to talk about offline.
Yes, but what
But I
I'm saying
agree.
is there are other reasons as well. And the RSVP, RFC that said applicability, you know, what went wrong with it is only some of them. And it really pays to look, you know, do a survey, people like me, people who have history in this. There are lots of us, we've all been burned by it. And just try and find all the reasons, because it's not just scalability.
so this one is not only about bandwidth reservation. So it also has queuing and scheduling.
Yeah, well, so did RSVP. Yeah, I mean, the guaranteed
So,
service in RSVP
yeah.
was hugely about that.
To try to reduce latency.
Yeah.
So I guess there are so many different queuing mechanisms people are trying to use, and we are doing the same.
RSVP, NSYS, they all had a service for low latency, you know, guaranteed delivery under a certain level. Yeah.
Okay. Let's take Fred's comment, and then we'll move over to Joe. We need to be.
Well, I'm basically thinking about directly responding to Bob's question, which was what was the issues with the previous time this was proposed. It was proposed by Larry Roberts, who you may remember was the program manager that originally funded the ARPANET. And he was starting a new company, and the algorithm was specific to his company. And that was kind of a big deal. People didn't like that idea. It was proposed in an internet draft in August of 2005. To my knowledge, it never made it to discussion in a working group.
I seem to remember giving you some agenda time, much to everyone being shocked sometime. But that's as far as it got.
Yeah. So I think it was using the hop by hop header, which at the time almost invariably meant a bypass to main CPU. And basically a system design thing, it just wasn't going to happen. There were many people with not only no, but kinds of comments. And to my knowledge, it was never discussed. So.
Okay, so there are people here who might be good to talk to try and explain really what can be done with new technology,
Yes.
because things do advance, or whether the opportunities that you think existed previously but somehow didn't mature. And I
Yes.
think you have to do that homework and figure it out.
Yeah, exactly. That's we'll do that. We'll do our homework, do our research, and we just want to see whether we can open a new door to build a new technology. Thank you.
Thank you. And two things that might help in the IETF context are if you get multiple equipment vendors to actually talk to you and agree on something, that would be huge. I mean, even if it's just kind of the whole idea, because individual companies coming to do this are
Yes.
not so well received here in general because we're talking about interoperability.
Yeah, sure. We will look for collaborators, and we'll also do some research, see other vendors' hardware, whether they can do the same kind of thing.
One question, would this be a better topic for congestion control research group?
I don't know because I don't quite know what this is yet, because if it's a new signaling protocol, yes, but, or not, I don't know.
Right now, this looks like a reservation protocol. There was some related congestion control ideas that would have gone to ICCRG. I think they ran out of time. I think they ran out of time in London. I at least had viewed this as a reservation protocol as opposed to, and not a congestion control management protocol.
Well, so why are you
I'm sorry?
If you're not trying to manage congestion, why are you doing the reservation?
Because you're trying to manage a service that has resources that are dedicated to it in a fashion the service uses it, and the service use thereof enables it to avoid congestion.
Let's try and see if we can get.
Oh, we have a
Right.
separate
Let's see if we can get-
congestion control draft on this topic.
Yeah.
That was presented last IETF. So
Right. Let's
can look it
let's see
up.
if we
Thank you.
let's see if we can get Joe up here. One last try. Slides are there.
Okay.
Trying to send audio. Can you hear me? Can you hear me? Can you hear me at all?
Whoa! Hello, Joe. We are so glad to hear you.
Okay. Am I coming through too loud or
Too soft.
too soft? Okay, I will speak up. I have never been known to be shy
Better.
about that.
Still soft, but it's better.
Okay. This is a summary of the state of UDP options. Next slide, please. Okay, so a bunch of items were updated. I really appreciate everybody's input into this document, and it was the only way to find all these bugs. Tried my best in the last pass to catch most of them. The ACS calculation was buggy, and it should be fixed at this point. It's on the payload only, and 0 has no special meaning. The frag option's been clarified as well in terms of the UDP checksums based on the datagram and the pseudo header upon fragmentation and reassembly and all that. The light's been clarified as well in the case when the light area is less than 4 bytes. Everything just slides forward. And we corrected the description of UDP light. We augmented the list of required options and reordered them. I apologize if that affects people implementing things, but at some point, anybody who wants to do interoperability, just use the latest version and pick the right numbers and it should all work. There's a reason we're trying to say that, okay, everything that's below a certain number is required. Light needs to be there. And that's because if you don't put light there, then light plus frag doesn't work anymore. MSS is used for PLP MTUD. That's Gory's draft. Frag is very important for DNSSEC, so all those are included right now. We don't include time, and the reason for that is that time itself may not be available as much as it's encouraged for even TCP. There's no requirement that nodes actually know what time it is when they do anything, time of day perhaps. So we're not sure how to include that or whether to include that as required. Next slide. And please don't take that list as gospel. Go to the draft. That's the best way to get everything. Okay. There were some other proposals that were discussed on the mailing list that have come up many times before.
We need to do something on the previous slide.
Oh, okay. Go back one.
So Tom Jones here.
Yes.
Just on the hosts not having time available, while they might not have a view of real time, there have been quite a few changes for TCP timestamps recently in Linux and FreeBSD to disconnect them from a notion of real time and randomize the start point. And so if hosts have a notion of an increasing clock, surely they can use the time option.
Yeah, I'll look into that. We can. One of the other reasons is that we don't want to put a requirement inside UDP that would put a mandate for something in some sense outside UDP, and it's unlikely somebody would implement a clock just inside UDP. So if the system itself doesn't have a monotonically non-decreasing value somewhere, to expect that it's part of the protocol might or may not make sense. And so that's...
Sorry, and just clarify, so the requirement for the option is that the host can parse the option and not that the host can send the option. And so a host being able to echo the ECR value doesn't require that they have to carry a TS val themselves.
We'll have to go through the possibility. We'll have to go through what it means to support to require to support the options.
Okay, thanks.
All options have to be parsable in the broad sense that there's a generic format for any option that's the kind and length, except with a small number of exceptions that are already fixed at the time of the definition of this spec. And so all new options are always parsable in the broad sense of knowing whether to skip over them or not. Whether or not to participate in the option, that's a question. So we have to go through that to make sure if that's possible. Like I said, I don't mind if we think that's something we want to add, but I want to be careful about making it a hard requirement, because even in TCP, as far as I can tell, it's not a hard requirement that you have that count. It's recommended, but it's, if you don't support it, you don't support it. So I want it to be able to be the case that you have a system that is in an Internet of Things device. It doesn't have to have a counter somewhere. Right? Just trying to keep TCP as lightweight as possible. Okay, so on the next slide, there were other proposals having to do with the TLV type length value for all options versus using a fixed header plus some TLV extensions. The thing is that the TLV, the fixed header will not avoid the need to parse things. The only way we can avoid parsing things is to get rid of light or to bury light in the fixed header. Otherwise, you have to parse the header to find out if light's there, because light will reorder things. And if light reorders things, it changes where your checksums are and everything else. So I don't see a way around having endpoints have to walk the header, which is pretty much what has to happen in TCP for extensions as well. And keep in mind, this option area for UDP is supposed to be like the TCP options in that sense. One of the questions had to do with whether making OCS mandatory and first. At most, it saves like a byte. And it would be more work to move frag plus light, because now that's 4 bytes and all of a sudden it would be 6. And I'm just not sure that's a win. And if you make it mandatory, then we also have to handle the case where it's 0, because just, maybe people don't want to use the option, use the checksum. Right now it's optional. So I have not seen a convincing case for putting that in as mandatory. The EOL versus option length field, the length field doesn't avoid parsing again, because again, the light could require reordering before computation on things. And the length costs 2 bytes more, whereas the EOL, in most cases, packets will not have an EOL at all. The EOL is only there if for some reason we find a way or find a need to have space beyond the option that is not covered by the options. Okay, and it's there largely, frankly, to be corollary to the way TCP works more than anything else. I didn't have a specific reason for putting it in there. The OCS size, the checksum of the head, this option field itself, the question is whether it should be 8 bits or 16 bits. I understand that if it's, if it's 16 bits, there's less false positives, less false negatives of things. It's exactly the same algorithm either way, except for about 2 opcodes at the end to fold the thing over and deal with the carry. But otherwise, it's the same algorithm. It's IP checksum, the internet checksum, and then you either stick it in there or you fold it over and stick it in there. If you fold it over, there's a possibility that you won't find an error when an error did exist, or we might not have this detection that would happen if other people happen to be using this area for something that isn't the option area. But over time, a given stream of UDP packets, it's going to trip up either way. So I don't think that size issue is a big deal. I think it's more useful to just make whatever field we pick aligned with whatever byte length we want it to be, and pick one. So I'd like to hear from other people on the list. I've heard from a few people on the list about most of these things. I'd like to hear from new people on the list about all these other proposal issues. Right now, in the last slide, the to-do items. I know that I have to put in more detail from RFC 7323, because the way UDP uses time and the way TCP uses time are not exactly the same. And we want to have it be clear what it is. The question is request defined as reply equals 0? So if I send the field, and if I send that option, and there's a request and a reply in the same option, and reply is 0, does that mean a request, or do we need to have 2 different options for this? I'm hoping we can do this with one option and sort of flip things around like that. Should we sacrifice a bit in the header in this time that's, in the high order bit and have that mean please reply so that both sides can be non-zero? Or can we set our TS value to 0 to say don't respond? I don't know the details of this. I want to work that out. I think Gory's more involved in this than anybody else. So we want to get the details of this right.
Hi, Joe. Sorry, Tom again from the floor. Gory made a very severe face at me when you said that, and I think you're misrepresenting this idea as something of his.
No. Oh, no. Let me back up. This isn't his idea. He wants to use it. I thought so. In a draft that he's working on. And if I got that wrong, I'll correct it. But I thought this was something you were using.
It's Gory at the mic. We need a way of sending a segment through the network as a probe for the PLP-MTUD draft. It's got a D at the front. So this draft needs a way of getting a response. I don't know that we want a timestamp for doing this. We want a request response way of doing this, and that's kind of what we're using quick. So this is kind of what we're wanting from here. Do we need a timestamp?
Identifier in there. If we were going to use the timestamp as the identifiers.
No, we don't want to use the timestamp as an identifier. I mean, particularly, we would like to use another identifier as the identifier, like we're going to use in quick. So we have an identifier we want to send, but it's not necessarily a timestamp.
Why wouldn't it be a timestamp? I mean, if the timestamp gets reflected on the other end, isn't that equivalent to the an identifier for the frame or for the segment?
No, it's not the same thing. We wanted something that was kind of like more known by the sender and not known by people off path. Whereas timestamps, I think, are known by people off path.
Well, not necessarily. It's monotonic and non-decreasing. We don't know anything else about it.
Okay, Tom. Would somebody talk?
Okay, Joe. So the problem with timestamps is that they can be coalesced by the host. And so you can reduce the timestamp space down to your most recent timestamp, and that's what you get echoed. With the probe mechanism we've suggested, you're always getting a response that is tied to a request. And then we can use a more dynamic token than something that has to monotonically increase for this space. We want a mechanism for sending heartbeats and for sending probes, so we can see if our traffic is working on the network, and a separate mechanism for doing RTT estimation that we get with the timestamp. These are very importantly two different things.
Okay, we'll talk about that offline then, and get the clarification of what needs to happen. But what I'd like to do is to hopefully find a way to have one field, even if it's one option for timestamp and one option for these probe values. I'd like to avoid a request option and a response option is really what it boils down to. Because I think there's a way of having all that in one place.
So what's the intention of avoiding a request and a response option, Joe? Because we can't spare two options?
No, because I don't. Well, if you're using it on a regular basis, it wastes a lot of space.
Wastes a lot of space. Well, it's okay because Path MTU Discovery isn't used on a regular basis, so this is cool for us. I mean, we're talking about one probe every 10 RTTs when we're busy.
Okay.
And it's always valuable. It's always kind of the most important thing that we need to discover about the path to drive the algorithm.
Okay, let's take it offline and we'll figure that out then.
Okay, it's useful to talk. Thank you.
Yep.
Okay, sounds good.
Yeah, so no, we do need to work that one out. And again, the question of the OCS checksum size, whether it should be 1 byte or 2. Really, what we're checking for is not really in-transit errors, frankly. We're really checking for whether somebody is using this space for something else. And so that's why I don't personally think it matters that much whether it's 1 byte or 2. I don't think we need something very, very, very robust. It really, for all intents and purposes, is, you know.
Make sure you write that rationale clearly in the draft,
Yes.
because at least my reflex and a number of other people's reflex is looking for strength against in-flight bit flips. And that's not what we're after here. That needs to be clear.
Yeah, in-flight bit flips, if they're not caught by something else, I don't know. The internet checksum is just not a great thing for catching that sort of thing in general anyway. I mean, yeah.
Okay, it's Gary here. I'm going to put my chair hat on at the moment and suggest that we talk offline. Maybe we can go through some of these issues with us and anyone else who's interested. It's a little after the end of the session close. There's not that many people here in the working group at the moment. So if you want to make some final comments, that would be fine. If anybody else has anything burning that they want to ask Joel, that would be okay. But the audio's not working that brilliantly either at the moment.
Yeah, no other comments from here.
Brilliant. Has anybody else in the room got any comments? Apologies for the various hiccups that have happened with getting things working this meeting. But we at the front have enjoyed it and hope you also have had a profitable IETF here. Thank you, Joe, for your remote presentation. Thank you, everybody here. Please use the list. We have lots of things to talk about. See people in Bangkok.
Thanks, everybody.
Thanks, Tim. Yeah.
Thank you.
Yeah, because, whatever. Thank you. It was feeling like on the edge, wasn't it?
Yeah, it was right on the edge.